Good evening, everybody. Welcome to our sixth and final session of the Utah Wing Virtual Communications Conference. It's good to have you here. We're excited to have our guest speaker tonight. I'm going to have Major Mike Collette, our Wing Director of Communications, introduce him. Just for housekeeping, if you have any questions, up in the top, I believe on the right-hand side, you'll see a Q&A section. You can enter your questions there, and we will see them. If you have any technical issues, please enter them into the Q&A also, and I will see those and try to take care of them as best I can. I'm going to turn the time over now to Major Mike Collette. Go ahead, Major.
Thank you, sir, and good evening, everybody. We're delighted to have Chuck with us tonight. Major Chuck Broodcall is our operations chief at National Headquarters with the Civil Air Patrol communications team. He's probably one of the most experienced communicators on the CAP roster. Has done, oh gosh, an immense amount of contesting in the amateur radio world on HF. Has a superb HF station that we're all kind of craning our necks to see as he checks in with the video on the national communications team calls. So yeah, Chuck has agreed graciously to serve as our keynote speaker tonight. This session wraps up our virtual communications conference, which has served to be our communications conference for this this calendar year. There's a lot of interesting things happening on HF radio. Some of these things you might be aware of. Some of these things I'm betting you're not going to be aware of. I know that everybody that's online is not an HF operator, but it's really important to know that when the commercial infrastructure goes down, you know, internet, telephone, text messaging, etc., about the only way we have for long-haul communications to region and back to national headquarters is HF radio. And even the Air Force is leveraging CAP to use HF because a lot of their HF infrastructure has gone away as they've gone to satellites, and now they're realizing, well, satellites can go down too. So I'm going to let Major Broodcall fill in the rest of the introduction, and sir, we'll turn it over to you.
Okay, thank you. I'm Chuck Broodcall. I'm not going to add too much to that because I think we have a whole lot of information to cover this evening. You did mention amateur radio. Yes, I am a ham, WA0ROI. My ham life has been DXing for the most part, so it's been very much intimately wrapped with HF. And I'm not #1 honor roll, but I am on the honor roll. So that's my life in amateur radio. Now let's talk about Civil Air Patrol. And when I was approached about this evening, I was asked to talk about HF, or high frequency. What is it? How is it? Or how do we use it? And why do we use it? Maybe touch on HF nets and on the air procedures. Hang on. Of course, the radio starts squawking in the middle. Anyway, and on the air procedures. What is high frequency? And again, I've tailored a lot of this to people that may not be familiar with HF, and it's from a very high level, but at least introduce them to the principles. HF radio is generally considered to be that portion of the spectrum between 3 and 30 megahertz. Its primary use is long-range communications versus VHF, which is short-range communications. HF propagation is highly variable compared to other frequencies, and our communications, our voice communications on HF is totally single sideband, very specifically upper sideband. For that matter, commercial radios tend to not even know what lower sideband is. That is unique to the amateur world. So whereas VHF is line of sight, you know where the other end is. HF propagation is you don't really know where your signal will land back on Earth again. Most but not all paths rely on the ionosphere. HF signals leaving your antenna, they go into space and they are refracted or bent. They are not reflected. They are refracted or bent in the ionosphere back towards Earth. These signals then again may be reflected from Earth back into the ionosphere, and this continues as the signal progresses around the Earth until it loses all of its strength. Very short paths are made via ground wave, and these paths are generally under 100 kilometers. Here's a picture, whereas your radio wave when it leaves your antenna is not a little narrow line like we have here on the picture, even though sometimes that would be advantageous. This just is intended to be a graphical representation of how things work. So your skywave, which is how most HF communications take place, go into the ionosphere. They are refracted back to the ground. A direct wave will be directly from your antenna to the far end antenna, which may be if this were an aircraft or if this were a mountaintop, for example. And then the ground wave hugs the Earth. But again, it only goes for 100 kilometers tops. Now this shows multiple bounces, and what this also shows is how different frequencies may be refracted differently in the ionosphere and hence may come down in a different location. Importantly, you have a space here between the bounces, and that space is often referred to as a skip zone because the RF skips over that portion of the geography, and you will have no communications by a direct path to that skip zone. So note that different frequencies react differently in the ionosphere. That is, they are refracted differently at different angles. If you want to learn more about HF propagation, there are many very good classes on propagation on YouTube, of all places. There's a lot of good information on the web, but I've looked at some of them on YouTube, and they're quite well put together. Now we have problems with HF, and we have some solutions. A lot of the problems we have there's nothing we can do about it. Mother Nature introduces all kinds of nasty things to HF. So our only solution for a lot of that is finding an optimum frequency to use for an intended paths, because again, all frequencies take a different path to get to the far end. To fill in that skip zone we talked about, there is a solution with a transmission method called INVIS, and we will talk about that a little bit later. But the primary solution, and our primary solution, is something called relays. We'll get into that in a moment. You will quite possibly have no ability to establish a direct path from where you are to where you wish to communicate. And again, the solution to this generally is via relays. Let's say that you want to communicate on this path, north and south across the state. That's not going to be too easy to do on HF. Some times of the year, sometimes of the day, it will be an impossibility. So what if we had another station in Atlanta and both ends of your path were able to communicate with Atlanta? Atlanta becomes your relay point to get information across that north-south path. Maybe the south end only has communications to Atlanta. The north end does not, but the north end has communications to Chicago. Chicago can talk to Atlanta. Again, there is your path. Now, this all seems complicated, slow, super slow, super inefficient, but is it possible with HF radio to pick up your HF radio telephone and dial up your intended party? Yeah, sometimes. Is it possible to pick up your HF radio telephone that is part of a robust network and exchange information with your intended party, nearly always. So even when the path is slow, it is still better than no path whatsoever. And that's what you must keep in mind. Some of the variables, we have uncontrollable variables, such as unfavorable ionospheric conditions, magnetic storms, solar flares. There is nothing that we can do about these directly. We have fixed variables that are unique to a station. Every station has a somewhat different transmit and receive antenna compared to every other station. If they both have the same model antenna, they may be installed differently. Hence, they react differently to the ionosphere and to incoming wave fronts. So that's a fixed variable. It can be, we do have control over it, but it's not something you can change in real time. The time of day or night, that is something you can possibly change. You're not going to have any propagation in the daytime, no matter what. Try it again at night. We have control variables, such as what frequency we use. Because again, every frequency, every channel in our radio reacts differently in the ionosphere. So some of the solutions we have is HF propagation knowledge, but not everyone has that. You have to be a bit of a radio geek to even want to learn propagation. Antenna knowledge. I think you probably have to be more of a geek to want to understand antennas, even though that was my favorite part of HF radio was antenna design, etc. So what do? We also use science, that is propagation, prediction, studies, and software. What the net control stations in CAP on the national net, what we tend to use is this URL, which is the Bureau of Meteorology out of the Australian government. And we use the HAP chart tool, where it will predict for the next 24 hours what our propagation should look like every hour. So if I want to know what my propagation is going to be like at 1900 Zulu tomorrow at 15 megahertz for the afternoon net, I can go here and I can find out. And I will know ahead of time what parts of the country I just plain am not going to hear. And I can start planning to manage around that. We also use technology, ALE, automatic link establishment. If you're using radios assigned to you by NTC, you have ALE capability. The MyComm 2s are capable. The MyComm 3s are compliant. There's a big difference. But I'm not going to get into, at this time, how ALE works. We are going to talk about that a little bit more. So sound planning, how do we plan a station? I mean, if we're building an HF station to use for continental US communications, there are some parameters we know that we need to plan for. We know what kind of antenna we probably need to use, etc. We have to look at what expertise do the operators have? How much help are they going to need in setting up a station? The most important thing in planning is to become part of a robust HF network. And robustness is defined primarily, in my definition, by the number of available HF stations on a network. CAP has a quite robust network. It's not as robust as what the amateur radio community has, where there are thousands and thousands of stations worldwide that may have their radios turned on at any point in time. But it is not uncommon for us to have 100 stations check into any one of our national nets. That's pretty robust for an organization. So again, this robustness is also aided by ALE. None of these examples, though, show a reliable, always there capability. Quite often, your path to the far end must be developed as you go. You get on the air to talk to the other end of the state, you have no path. You make a call for anybody that can help. Someone in Atlanta answers you, and on we go. One leg at a time, we build our path. Bottom line, with a large enough network, one will always get the traffic through. It's not necessarily efficient, but it's effective, and that is what we're after. Using relays to get your message through may seem to be quite inefficient. You know, it's all a matter of perspective. If using those relays to get your traffic across the state is the only way you can get your traffic across the state, the concept of inefficiency quickly fades away. Slow is better than nothing at all. If we want to do it fast, we'd use the phone. When we don't have infrastructure, we don't have the phone. So we have to try to make something work, and that's where this comes in. So planning. It can't be stated enough. Let's say that we are going to have a national net, and the NCS is in the state of Washington. Our propagation studies show us that at net time, the net control station is going to be blind to this whole portion of the country. Oh my goodness, what are we going to do? Well, we may have an alternate net control station in Florida. They should be able to cover at least part of this blank spot. We may have an alternate net control up in the Mideast. They can cover another part of it. This may be something that the net control builds on a step-by-step basis during the net. For that matter, it almost always is. This net control down here may or may not be a normal net control station. It may just be someone that checked in and has a good signal to the NCS, and that becomes the NCS's gateway to the rest of the world. I have had nets where I am a net control and have copied maybe 1 or 2 stations, period. But we ended up with 70-some stations checking into the net. One must remember when it comes to nets, especially HF nets, that the NCS, the net control station, their job is to manage the net. It is not required that the net control talk to everyone on the net. It's not required that the net control manage that the net control listen or hear everyone on the net. They manage the net. They can run a successful net and never talk to a single station other than 1 or 2 alternate net controls. So their purpose is to manage the net, not to talk. We have a problem as communicators that if we're holding a mic in our hand, then by golly, that means we are supposed to be talking in that mic. Okay, again, the more robust the network that you are part of, the more reliable will be the communications to any point on that network. And nationally, that's what we've been trying to do for a few years now, is get that robustness into the network. An HF radio with no network? Yeah, it's still better than no HF radio at all. In an emergency with a knowledgeable operator, it may become part of a robust network until the disaster is passed. It's a valuable tool in your toolbox. But again, a HF radio with no network is better than no HF radio at all. Why do we use HF? Well, it's a mature technology. It's over 100 years old. Local to worldwide coverage is easily achievable and reasonably priced. For that matter, worldwide coverage is often way easier than local coverage. Independent of infrastructure when using battery power, that means, you know, it doesn't require a service provider. It doesn't require a cell tower. It requires nothing outside your immediate location and that piece of wire you have for an antenna and the vehicle that you're using the battery out of to power the radio. It's simple. Follows the KISS principle. Keep it simple, stupid. So an HF radio user can communicate with any other HF radio user with no need for anything else other than the radio and the antenna. So HF radio is an added layer of protection against the total loss of communications. It supports continuity of operations when the infrastructure-dependent communications are disabled. In extreme situations, it may be the only means of voice communication. It may be your only ability to communicate within and or out of a disaster area. That is the reason Civil Air Patrol is pushing HF communications for continuity of command. That is the reason the Air Force is pushing Civil Air Patrol to push HF communications because of continuity potentially of their command. Okay, HF operations. We have today we have three primary things. We have voice communications via scheduled nets. These nets can be national nets, they can be regional nets, they can be wing nets. We have more random voice communications via ALE links, and this would tend to be from the National Message Center stations to today, primarily the wing message center stations. And we have message center stations. This is organized on a national basis in that we have the National Traffic Net, which are held 3 times a day, Monday through Friday. The NTN stations also monitor NRC and NRD when possible. For those of you unfamiliar with HF radio, NRC is a designator for a channel, just like your Romeo XX, where X is a numeral that you use on VHF. We do the same thing on HF. Another way to look at this, in your MyComm 3 radio, NRC is channel 3, NRD is channel 4. These are also the national calling frequencies. Ring, wing, and region nets may vary. The schedule for these is located in the Comm library. If you look at that and it's not accurate for your part of the world, please have your DC or DOKO know about it, and we will update that that schedule. That schedule gets updated sometimes a couple times a month. Sometimes it goes for 3 or 4 months. It just depends on the feedback. We also today have voice via ALE, the National Traffic Net, which are also the National Message Center stations, are on duty 24/7 on ALE Net 9. They also monitor NRC and NRD. They initiate traffic delivery to regions and wings message center stations. Now, the region and wing message center station, that varies by region and by wing. The message center station function should provide 24/7 coverage if possible. The message center stations are managed by either the region DCS Comm or the wing DC. The purpose of a voice net, number 1, equipment confidence. When I turn on this radio, is it going to work? Is my antenna still hooked up? If I push the button on this microphone and if I talk, is someone going to hear me? Am I going to hear them? In other words, equipment confidence. Also, operator confidence. A good operator works mainly from muscle memory. I don't have to think about pushing the talk button. I don't have to think about it. It's a habit. I don't have to think about using pro words such as over, or pro words such as out, or pro words such as say again. That's muscle memory. So the purpose of a voice net is to keep practicing that, to build the operator's confidence in their ability to actually participate and be an asset. And then we have discipline training, the most overlooked function of a communicator, and that is to be disciplined. Again, because you have a microphone, that doesn't mean you have to talk. Your microphone allows you to talk if you need to. One of the most valuable assets that a communicator can have is the ability to listen and not follow their impulse to talk. That is pretty amazing. And when you have a whole net of people like that, you have a very disciplined net and things move a lot more effectively. Okay, we are going to talk a little bit about ALE. The basis for much of our HF network, especially going forward, was something called CAP Direct, which is the new data network. Much of our basis is ALE going forward. It reduces the need for knowledgeable operators. For example, every vehicle in the nation that has an HF radio should have a one-page document that is a set of instructions so that anyone that happened to sit in that radio, or I'm sorry, sit in that vehicle could pick up those instructions, push the buttons on the radio, and make contact with someone for help. That's how simple it can be with ALE. Operators can be effective by merely following printed instructions. You must belong to an existing ALE network for this technology to work. All stations currently in CAP, your radios come that way. You do belong to a network. Your DC can tell you what ALE network you belong to. Currently, all CAP ALE networks are region-centric. That means we expect the radio waves to follow geopolitical borders. Radio waves don't know what geopolitical borders are. A radio wave leaving your antenna can easily land in Beijing as it does in Atlanta, and it will. So radio doesn't know. So what we're looking to do when the new regs come out that allow us to do this will be that we will most likely be changing these ALE networks to be geographic centric, more accurately reflect what radio waves do. So this is something to look for as soon as possible, actually. But again, it'll be using ALE. Now, ALE variations. Today, all of our radios use what's called 2G ALE. Virtually every ALE radio in the world today uses 2G ALE. This complies with MIL standard 188-141A, uses analog MFSK for signaling. This is what everyone knows as ALE today. We may be and will be, to a certain extent, migrating to a standard called MIL standard 188-141 Bravo, Appendix C, also known as 3G ALE, third generation. This is a synchronous network where every radio on the network is synced in time. Today, that's done via GPS, but again, GPS is also infrastructure, so we have to learn how to get around that. Everything communicates via data bursts. Today, this is currently found really only in tactical ALE systems, and few and far between. It will soon be found in CAP, at least on our backbone data network. Now, the components of a voice station. If you get your radio from CAP National Headquarters, it will be an NTI compliant radio that will be a Motorola MyComm 2B, 2E, 3F, or 3TS, and maybe one or two other variations out there. These are all NTIA compliant radios. Some members have their own radios. They may be a MyComm 3F. They may be an SGC. It may be a C, Stevens Electronics and Associates, I believe it is. Basically, every radio made by C was NTIA compliant. ICOM, Codan, Barrett, all of these other companies, for the most part, make radios for the maritime industry. And so they can be bought fairly cheaply on eBay. Many of the national net control stations are using an ICOM ICM 710. These can be purchased for well under $500 on eBay. Why? Because the maritime industry has gone to newer technology. Why do we do it at our own expense? Because a lot of us are radio geeks and we like to play with radios. And we can connect other things to that ICOM M710 to play with, which we cannot do to a corporate MyComm 3F. There's nothing wrong with you doing that. Now, you will not have ALE unless you spend the big bucks for an ALE radio, etc. A voice station power source, all you need is 12 volts. This can be a battery maintained by solar. It can be a battery maintained by wind. It can be a battery maintained by the charger in your vehicle. The antenna, larger is always better. Almost the case of you can never have too much wire in the air. But even a small antenna, let's say an 8-foot mobile whip, can be effective. So if you live on a postage stamp size lot, you can put up an HF antenna that will be effective. Not as effective if you had 100 foot of space to hang a larger antenna. Now let's talk a little bit about message control stations, or message center stations, I'm sorry. This is your incoming link from National Headquarters Message Center Station. This is your link to the NOC and to other agencies via the NOC. If the DoD has a tasking for Civil Air Patrol for the Utah wing and the infrastructure is down, that tasking is going to get to NOC via a national message center station. NOC will then kick out the order, which will again go to a national message center station and will try to find one of the message center stations of the wing. The wing then needs to have a subtending path to the wing command structure. Now that's dependent on each wing. In other words, who in your wing can mobilize assets? Who can launch an aircraft? Who can bring people together to get on that aircraft? That is the person that you need a path to as a message center station. That path can be VHF radio. That path, as I've mentioned in the past, can be super simple. I'm the message center station operator. I print out the order. I get on my bicycle and I go two blocks to the IC1's house and hand them the paper. It doesn't matter as long as it's documented, tested, and everyone knows about it. That's the important part. Message center station function should exist in every wing. The function may comprise several stations working in shifts. All wings are authorized a minimum of 3 MCSs. That means that this equipment is totally outside your table of allowances. Each MCS is authorized 2 MyComm 3F radios and 1 VHF radio. NTC is currently shipping these radios. If you have any questions about a message control or message center station, contact DOKO at this address. There is a web application that you fill out, is actually filled out by the DC. The DC then the DOKE engineering then contacts the subject station, determines what their technical needs are when it comes to power, when it comes to antennas, and then that order is put into NTC and the equipment is shipped. Again, it's an online application. MCSs are managed at the wing level by the DC, hence the DC has to put in the application. HF interoperability. We hear about that a lot, even if you're only familiar with VHF. Everyone knows what the NIFOG is. Everyone knows about those programmed frequencies in our VHF radios. That's where we go when we need to talk to somebody else. Now, what a lot of people may not know is we don't own those frequencies. Technically, we can't tell other people come there and meet us They have to ask us to come there and meet them. The only time we can ask someone to come meet us on a frequency is if we have a MOU with that organization, and that's a whole other thing we're not going to get into here. So as with VHF, we can go anywhere in the spectrum, in the HF spectrum. We can go anywhere. We do go anywhere, but we have to be by invitation. Has to be by invitation. Likewise, we may invite other entities to use our channels to communicate with us. An example of that is we have a yearly exercise with the Royal Air Force Air Cadets in the United Kingdom. We use US DoD frequencies, the ones that are assigned to CAP. We provide those to the RAF-AC. They go to the Ministry of Defense and get permission every year to operate on those frequencies. Last year, we had to shut it down because all of their HF stations are on RAF facilities, and due to COVID, there was no access. This year, I just haven't had time to get it fired up yet. We do already have permission from the Ministry of Defense for, I think, 10 of the requested frequencies, and we'll get that plan together as soon as possible. Also, if you are a ham, you know about 60-meter channel 1. And it seems like everyone goes there to meet, don't they? Mars will put on an exercise and meet the hams on 60-meter channel 1. Why doesn't CAP do that? Well, to start with, Mars does not own 60 meters channel 1, neither does Civil Air Patrol. That is owned by FEMA. So first of all, what Mars has done is gone to FEMA and said, can we borrow 60-meter channel 1 for an interop exercise? At that point, they get the hams together and everyone goes there to talk to each other. And that's perfectly legal. If we were invited, we could go there too. For that matter, for a monthly exercise in Region 10 of FEMA, we are invited and we do potentially take part on 60 meters channel 1. Why doesn't CAP do that? We could. I could call up the frequency manager at FEMA and say, can we use 60-meter channel 1 for an exercise between the hours of this and that on this date, and we would, in fact, get permission. The thing is, we do not have a mission need to do that. Our mission does not include interoperability with the amateur world. Mars mission does. That's the reason they do that. So I'm just throwing that out there. So today we communicate on HF with Department of Defense. They come to our channels. We go to their channels. We communicate with FEMA on the NECN, the National Emergency Coordination Network. Those frequencies are built into our code plug. And we communicate with other federal agencies via SHARES, which is a Shared Resources Network, which is run by Department of Homeland Security. That's that for interoperability for right now. So let's get back to voice versus data. Voice is simple. It complies with the KISS principle. Keep it simple, stupid. It's the fallback method when everything else fails. All you need to communicate on voice is a radio that works, something to power it with, something to use for an antenna, and a microphone. You don't need anything fancy, and you will be able to communicate. It is the fallback. It will always be there. We will never discontinue using voice communications on HF and Civil Air Patrol. It is the fallback. Data, on the other hand, gives us a more efficient exchange of information. We even do that with encryption. I mean, it's not going to be a what if. We will be using encryption for our data. The data network path selection is automatically part of the process based on routing tables, based on ALE. and it allows automation. Theoretically, our by the time it's mature, our data network will be pretty much automated, and we'll be able to pass traffic toward its destination without a human touching a key. That's not to start with, but we will be getting there. Right now, a data station will consist of a radio, currently a MyComm 3F. Once we get new HF radios, it will probably be the new HF radios. It consists of a physical data modem, currently made by RapidM out of South Africa. This is a Department of Defense requirement. Not the RapidM, but the physical data modem. We are required to not use anything that is software derived. No MT63, no FT8, none of that. The data terminal is a dedicated laptop computer that must be air isolated from the world. That is the only connection that comes out of that laptop is the one to the AC power and one to the modem. The terminal software and that terminal was developed specifically for CAP and is still under development. It will continue to be developed as we become more and more automated. The CAP Direct system is currently in beta test mode. We're just getting started with that. Basically, the beta test is around the documentation because it's complex. It's some complex software, but we expect anyone to be able to use it. So the instructions have to be good. Data equipment for this network will primarily be distributed to the Wing Message Center stations to begin with. And again, the data software is developed for CAP. Our data will be using the HF standard, MIL standard 188, 110, which in the amateur world, we used to call that RIDI. We will make use of USMTF, United States Message Text Format. This is at the request of our DoD partners. This not only supports encryption, basically encryption is pretty much mandatory. It also supports ACP 127 message procedure standard. That is what we are using as our standard to work against. Okay, what procedures do we have on HF? A very important one, and I can't stress this enough, is discipline. All nets, I don't care if they're VHF or HF, but especially HF, where conditions are generally less than ideal, discipline is what it's all about. Our discipline is derived from ACP 125G. This is Allied Communications Publication 125G, Communications Instructions. This has been around since the 1940s. Our current CAP regs do not point to it. Our CAP regs that are coming, that are awaiting approval, point to it. Everything points to ACP 125G. You can download this. It's available online. It's available in the CAP Communications Library. If you want to read that, pay special attention to pro words. Pay special attention to message handling procedures. That is where we begin deriving the discipline. And again, as I've mentioned before, patience is the most important skill a communicator can have, especially on HF channels. The ability to listen. The ability to listen. The net control station always controls all aspects of a net, including who talks and when they talk. You don't offer a relay until net control asks for a relay. To do so disrupts the continuity of the net. Discipline is what it's all about, and we base our discipline on ACP 125. OPSEC, this has become so important. Be careful of what you say on an HF radio, as your audience, not maybe worldwide, but is worldwide. A few years ago, I received a QSL request from Germany. That was back when we had the old call signs. I received a QSL request for Iowa Cap 4. The guy didn't know if CAP had QSL cards pre-printed, so he had one made up, designed, and pre-printed with the Iowa Wing emblem on it. I have no idea how he found out who I was, where I was, etc. Avenging Spirit, within the last 10 days, received a QSL request from Switzerland. Our signals do go all over the world. So for those of you that don't know what a QSL request is, there is a hobby out there called shortwave listening. And that hobby may be just seeing how many stations worldwide you can hear. I used to do that back in the 60s. I had QSL cards from Radio Tokyo, from Radio Moscow, et cetera, et cetera. And those QSL cards just proved that I listened to them. You would write to that station and tell them what you heard, and they would check that against their logs and say, yep, they really did hear us, and they would send you a card. If you do get a QSL card request for a CAP call sign, just ignore it. Okay, the new communications CAP regs will cover OPSEC related concept called bead window. You can look this up today. Just beware that what we will be using will be a CAP-centric bead window. The bead window is a very valuable tool. It's a method to raise OPSEC awareness, and this process also provides on-air help for OPSEC issues. So it's a interesting thing. One of the new CAP standards is pretty much dedicated to it. Call signs. I wanted to cover call signs because there are some things unique about call signs that need to be discussed. Some of them haven't been discussed. Sometimes people don't know why we do something. First of all, a few years ago, we had to do a lot of work around OPSEC and to conform with a document called AFI 33217, which is from the Secretary of the Air Force. Approximately 1/3 of our organization's call signs went away so that we could become compliant. Some of you may or may not have been involved with that. So one thing that came out of that, and people ask, why does this rule exist in CAP today? One of the things in AFI 33217 is that HF call signs cannot have more than 2 figures after the basic call sign. So whiz-bang 22 is legal for HF and VHF. Whiz-bang 222 is not legal for use on HF in Civil Air Patrol. It is legal for VHF. So sometimes, and this happens on the National Traffic Net quite regularly, that someone gets on HF for the first time, they have been assigned a 3-digit call sign, and they just start using it on HF, not knowing that there's a difference. So that's why that exists. It's AFI 33217. Also, there's one other thing. Besides, we do have wing-centric and region-centric call signs. We actually have purpose-centric call signs applicable to a mission or an activity. For example, Billy Bear today is now used as a net call sign on the CSI net. It's also used as a call sign for the net control stations. The National Message Center stations have a unique call sign that is used solely when we go to shares nets. We try not to carry our identity across the spectrum. For example, if a DoD station calls me on a CAP frequency, and I am communicating with them as Fast Runner Tree, and they have traffic for my station, I will tell them that I wish for them to move to Romeo 102, which is one of their channels, and wait for Whizbang 33 or Whizbang 9er, whatever. I will not carry my call sign over to their frequency for OPSEC purposes. So this becomes very important. Call signs on HF become very important, and how we treat them. So the next two slides, I'm just going to touch on something. We don't have time to get into it. A collective call sign is defined as a collective of specific members. So today, Tri-Blade, the call sign Tri-Blade, is registered with the Air Force Voice Communications Office as a collective call that can be used to cover any and all CAP stations. Aspen Gold is by default a collective call for all stations with Aspen Gold as their root call sign. It's also used as a net call sign for probably for calling a Rocky Mountain region net. High Desert is default as a collective for Utah Wing cap stations. It's also probably used as a net call sign for the Utah Wing net. Now, what's the difference? A net call sign is defined to include participants of an activity. For example, we now use the net call of Clear Sky to define all the participants in the national traffic net, no matter their affiliation. When I call a net and I call Clear Sky, any station on that channel at that time of day can answer. I don't care if they're DOD. I don't care if they are Mars. I don't care if they're Royal Air Force Air Cadets. They can answer. If I want only cap stations to answer, I will call Tri-Blade. So this is important, not so much at the wing and the region level. It became very important at the national level. And what I intend to do when the new regs get out and allow us a little more leeway, we have been putting together a stash of call signs. So let's say you have a mission going that covers wings in 2 regions. What would you use for a net call sign to make sure everyone knows who you're talking to? You want to use, main sweep or Western, because then anyone can answer whether they're part of the mission or not. So what about if we assign the call sign Whizbang as a net call sign to cover this specific mission? And you could use that call sign for the duration. If you have exercises upcoming where you want that to happen, you want to test that, contact me via the DCS Comm, and we will assign a call sign for it. Hopefully in the future, what we will be able to do is put out a index of those call signs. If you have a mission come up at a moment's notice and you need to do that, you grab one of the call signs from that list, you start using it, and you let DOKO know. So that's why I wanted to cover the net and those kind of, and I'm out of time. Okay. Invis, here is a URL that you should use. Invis is not a solution for everything. Invis is a good technology. It's not new. It was not invented in 2015, like a lot of people want you to think. It was actually used by the Germans in World War II. Most cap station antennas are by definition already Invis, which means they're less than 55 feet in the air. Of course, the lower they are, the more enhanced they are for Invis. That's what Invis looks like. It makes things go straight up and come down. Avoid going for marketing schemes to call an antenna broadband. If the marketing is aimed at the amateur community, that means it's broadband and that it'll cover all amateur bands. That doesn't mean it covers all frequencies. Likewise, an antenna that says it'll cover 80 to 6 meters does not cover 3.5 to 50 meg. It covers all ham bands. So if you have questions about antennas, either let me know or DOKE, and they can help you out. Right now, all National Message Center stations must sign an NDA from the Department of Defense. Basically, this is going to be expanded to all CAP direct operators, even at the wing level. We also, all National Message Center stations must take annual DoD OPSEC training. This will also be expanded effectively to all Comm officers. And here's my last slide. So we didn't skip a whole lot. If you need to contact any of us for these various issues, here are our email addresses. And that's also my personal address, email address. And I'm ready for any questions, even though we only have a minute or so left. So.
There's none on the chat, but I'll watch for them. And I have one maybe to kick things off. I suspect you have a pretty impressive antenna farm. I haven't seen it. I haven't seen pictures of it. I suspect it exists. But one of the bottlenecks to getting new HF stations on the air, of course, is getting the skyhook in the air. What advice would you have for a prospective HF station for a simple to erect HF antenna as kind of an HF starter antenna? What ideas would you suggest they think about?
Okay, probably the most effective all-around good antenna, and NTC will send you one of these, is called an inverted L. And that is a wire that goes up in the air and then goes horizontal. It has a tuner at the bottom, which NTC also sends you. Today we're using, I think we're still, well, wait, we're changing. We were using SGC, SG230s, but we ran into supply problems. We may have switched to the LDG AT600 remote tuner. But an inverted L is very simple. It's inobtrusive. Your neighbors aren't even going to know it's there. And then a NTC also sends out probably 4 wires to lay on the ground for radials. I think they're 30-foot long. That greatly impacts the efficiency of the antenna. And at least for a starter antenna, it's hard to get any better than that.
What would you use as step 2?
Step 2. Well, then I would probably, in today's propagation environment, I would pretty much avoid a vertical. I've got 4 verticals on the property, and it's on a net here about 2 weeks ago. I actually got to use one of them. Other than that, for the last 18 months to 2 years, they've been worthless for stateside communications. For stateside communications, you need an antenna with a fairly high angle. So step 2 is might be what's called a T2FD, which is also an antenna that NTC would ship you, but it takes about 100 foot of horizontal room roughly to put it up. And it's kind of ugly, but it's a very low noise receive antenna. And I actually, where I used to dislike those antennas in the worst way possible, under the conditions we've been working under for the last 12 to 18 months, unfortunately, they've become my go-to antenna. I've got 2 of them up here. So,
and for those on the call that have used some, that's essentially the B&W folded dipole he's talking about.
Yeah. It's a very quiet and low noise antenna. And one of the things that people forget about is what we do on HF with the continental communications is we're not trying to talk to London. We're not trying to talk to Berlin. We're not trying to talk to Taiwan. We're trying to talk to the next state. That's a whole different set of antennas. We tend to do that on low frequencies. Low frequencies tend to be very noisy, from lightning, you name it. A T2FD or the B&W folded dipole is very quiet. The signal to noise ratio on receive is is way better than that inverted V or inverted L that I talked about, which would be a noisy antenna. As we always say in radio, you can't talk to them if you can't hear them. So
I don't see new questions, and I think people probably have an evening to get to, but certainly anyone that wants to send questions to myself or Lieutenant Dyke or even to Major Broodcall after the fact, please pose them, because we want to make sure that any questions you have, we get you our best answer. So, sir, thanks for joining us tonight, late at your end, for kind of a primer on HF operations, and we'll have those email addresses available. And I think the session is also recorded. Is that correct?
That is correct.
So you'll be able to.
Yeah, after this session, you can just go to the link that you went to today to watch the live session, and you'll be able to see the recorded session. I actually have one question for Major Broodcall. What is the length on that inverted L?
oh, what they are shipping. Oh my goodness, I don't know how much wire they're putting into there. Maybe a total length of 70 foot, but it doesn't matter. It does. I have inverted L's here that go up 10 feet and go out 20 feet and variations thereof. I use them mainly for, you know, some of these extra radios around here. But I think they send you something like 70 foot of wire, and it's pretty high-tech wire. It's a Teflon coated wire that we're buying in bulk out of England, and you cut it to length. I mean, and that doesn't mean that your horizontal thing has to go over to something horizontal and stop. The far end can drop back down toward the ground again. You know, you can never have too much wire in the air.
No, I understand that. You just have to have enough room to put that much wire in there.
We have stations. I don't know. I should not bring up. I'll just bring it up by call sign. If you could see where Red Fox 17 lives, you would say that there is no room for an antenna. For that matter, I think his antenna is in the attic of a one-story house. But he is such a tenacious operator that he probably makes it into every net and also moves traffic. So anything is possible. It just takes more patience.
Cool. Okay. Well, Major Collette, I might be able to do HF after all.
That would be great.
You know, I've got a 90-foot circumference loop. I'm in an HOA. So I have a 90-foot circumference loop in PVC in a trapezoid shape tacked to the side of the house. So nobody can see it because it's the same color as the house. It's not very efficient, but with the relays that you spoke of tonight, I can generally get into one of the nets, and it's just not a very fun antenna to have to use. It is what it is.
You know, HOAs are a problem, but I'll tell you that in the ham radio world, again, I'm a DXer, or I used to be all the time, until I got to start doing this, and suddenly I have to worry about local communications, which means it stays within the continent, you know, to a DXer. And a friend of mine that was a DXer that bought a townhouse in Minneapolis, went up there for a weekend, and by the time we got done, we had him operational on every band from 80 through 10 meters with antennas that you could not see looking at the house. That included a 3-element Yagi fixed on Europe that was made out of wire stapled to the rafters inside the attic. He called me first thing Monday morning, all excited. He had just worked the Isle of Man on 10 meters. It was a full wave loop, which was around the molding of a window on the second floor of his house. You can hide antennas in plain sight. It is entirely possible.
Yeah, I'm less worried about hiding it. It's the space. But anyway, thank you very much. I see attendees kind of dropping off, so it's probably, getting that time of the evening. We really appreciate you, Major Broodcall, for your time and expertise that you shared with us tonight. Again, thank you to Major Collette and for Major Roads for putting this all together. It has been quite a good experience to be able to produce these over the last several months. And this was our last one. If you do have any questions related to communications, please feel free to reach out to Major Roads, to Major Collette. You can send things to me, and I can get them to them if you can't. And everybody, thank you very much and have a wonderful evening.
Thanks again, and be safe out there.